Hi ladies and gentlemen, welcome back. Today I'll talk about the core components of a virtual machine and explain how virtualization technology can be leveraged to improve efficiency and business continuity within an organization. As modern businesses continue to grow, they require IT environments that are flexible, secure, and cost effective. Organizations can no longer afford to purchase separate physical servers for every application or service they deploy. That challenge led to the widespread adoption of a virtualization technology, which has become the foundation of modern data centers and cloud computing platforms. A virtual machine or VM, commonly referred to as a VM, is a software-based computer that behaves like a physical computer. It has its own operating system, applications, storage, memory, and networking resources. Okay. Although multiple virtual machines can share the same physical hardware, or each VM operates independently and remains isolated from other VMs. To understand how virtualization works, it is important to understand the core components of VM. The first and most component is the hypervisor. The hypervisor is the software layer responsible for creating, managing, and allocating resources to VMs. It sits between the physical hardware and the virtual machines, ensuring that each VM receives the resources it needs while remaining isolated from others. There are two primary types of hypervisors. Type 1 hypervisors, often called bare metal hypervisors, run directly on the physical hardware. Examples including VMware, XZ, and Microsoft Hyper-V. Type 2 hypervisors run on top of an existing operating system such as Oracle VirtualBox. In enterprise environments, Type 1 hypervisors are preferred because they offer better performance, scalability, and security. The second component and the most of virtualization is the virtual CPU or vCPU. Okay, the vCPU represents a portion of the processing power provided by the physical server. The hypervisor distributes physical CPU resources among multiple VMs, allowing each VMs to execute application and process data efficiently. Without virtual CPUs, a VM will not be able to perform any computational tasks. The third component is virtual memory, commonly known as VRAM. Just like a physical computer requires memory to operate, VMs require memory to run operating systems, applications, and services. The hypervisor allocates a dedicated amount of memory to each VM. This ensures that workloads remain isolated and that one virtual machine cannot directly cancel the memory allocated to other virtual machine. Okay, and the fourth component is virtual storage, often called as virtual disk or VDisk. VDisk stores the operating system, application files, user data, and configuration settings of the virtual machine. Unlike traditional hard drives, VDisks are typically stored as files on the host server. This makes them easy to backup, replicate, migrate, and restore when necessary. The fifth component and the most is virtual networking. Every virtual machine uses a virtual network interface card or VNIC to communicate with other systems. VNIC or virtual networking allows virtual machines to connect internal networks, cloud services, databases, and the internet. Through virtual switches and software-defined networking technologies, administrators can create secure and isolated network environments without requiring additional physical hardware. Now that we understand the core components of a virtual machine, let's examine how virtualization can be leveraged within a business environment. The first major business benefits is server consolidation and cost reduction. Imagine an organization operating separate physical servers for Active Directory, file sharing, email services, database management, and web hosting. Each server consumes electricity, generates heat, requires maintenance, and occupies physical space. Instead of maintaining 5 separate servers, virtualization enables the organization to run these workloads as independent virtual machine on a single powerful physical host. This significantly reduces hardware acquisition costs, power consumption, cooling expenses, and administrative overhead. As a result, organizations can maximize resources utilization while lowering operational costs. The second benefit is disaster recovery and business continuity. Unexpected events such as hardware fails, cyber attacks, software corruption, or natural disasters can disrupt business operation. Virtualization greatly simplifies disaster recovery because VMs exist as files that can be backed up and replicated. Okay. For example, if a production server experiences a fail, administrator can quickly restore the virtual machine from a backup or migrate it to another host server. This minimizes downtime and helps organizations maintain critical business operations. The third business application is development. Okay, testing and sandboxing. Software developers and IT teams frequently need to test, update security patches, and new applications before deploying them into production environments. Virtualization enables administrators to create isolated test environments without purchasing additional hardware. If a test fails or introduces instability, the VM can be deleted or restored from a snapshot without affecting production systems. This flexibility encourages innovation while reducing operational risk. In addition to these benefits, virtualization serves as the foundation of modern cloud computing. Cloud providers such as Amazon Web Services, Microsoft Azure, or Google Cloud rely heavily on virtualization technologies to deliver environment as a service, commonly known as IaaS. For example, when an organization launches a virtual server in Amazon EC2, virtualization technology is being used behind designed to allocate compute resources securely and efficiently. This demonstrates how virtualization bridges traditional server administration and cloud computing environments. In conclusion, virtualization is one of the most important technologies in modern information technology infrastructures. Uh, Through the use of hypervisors, virtual CPUs, virtual memory, virtual storage, and virtual networking, organization can improve efficiently, reduce costs, enhance disaster recovery capabilities, and create flexible environments for development and innovation. As an aspiring cloud and server administration professional, understanding virtualization is essential because it performs the technological foundation of modern data centers, cloud services, and enterprise IT operations. Thanks for your time and consideration. I appreciate the opportunity to talk about this topic and demonstrate my understanding of virtualization technology and its practical business application. See you in the next video. Ciao.